As you can see, the data model in the following figure is quite different from the initial data model of preceding figure. Which one is better? They both can be valid models. It just depends on the world you are trying to represent and possible future queries. In the first case, the purpose was to determine the value of a portfolio. There was no interest in on which exchange stocks were listed or their home exchange. So the first model has high fidelity for the described situation. The second data model would be appropriate if the client needed to know the home. Defining attributes generally takes considerable discussion with the client. You should include any attribute that is likely to be required for present or future decision making, but don't get carried away. Avoid strong avoid storing unnecessary data. For example, to describe the entity student, you usually you usually record date of birth, but it is unlikely that you would store height. If you were describing an entity patient, on the other hand, it might be necessary to record height because that is sometimes relevant to medical discussion making. Relationship entities are related to other entities. If there were no relationships between entities, there would be no need for a data model and no need for a relational database. A simple flat file, a single entity database would be sufficient. A relationship is binary. It describes a linkage between two entities and is represented by a line between them. Because a relationship is binary, strictly speaking, it has two relationship descriptor, one for each entity. Each relationship descriptor has a degree stating how many instances of the other entity may be related to each instance of the described entity.